Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam, May-June 2024, paper 42. Let's start it. Question 1. A list of gases is shown. Answer the following questions about these gases. Each gas may be used once, more than once, or not used at all. First one. Which gas is the main constituent of natural gas? Of course, natural gas is methane. Second, which gas is responsible for both photochemical smog and acid rain? Nitrogen dioxide gas react with other gas pollutant in the atmosphere in very hot weather to form photochemical smog, which is a brown haze formed in many industrial cities. And because nitrogen dioxide is acidic oxide, it can dissolve in rainwater to form acid rain. So the answer will be nitrogen dioxide. Which gas is unsaturated? Unsaturated means it has double bond. It's alkene, so the suffix "ene" here represent alkene. The answer will be propene. Which gas has monoatomic particles? Monoatomic means it exists as single atoms. Noble gases exist as single atom. Here in the list we have helium is a noble gas, so the answer will be helium. Last one. Which gas reduces iron 3 oxide in the blast furnace? The reducing agent in the blast furnace is carbon monoxide. Question B. Nitrogen dioxide and carbon monoxide are removed from the car exhaust by catalytic converter. Write a simple equation for this reaction. Catalytic converter change the toxic gases like nitrogen dioxide and carbon monoxide into normal gases present in the atmosphere. So nitrogen dioxide converted into a nitrogen gas, which is normally present in the atmosphere. Carbon dioxide changed by the catalytic converter into carbon dioxide. So the equation will be nitrogen dioxide plus carbon monoxide form nitrogen gas and carbon dioxide gas. We still have to balance the equation. The equation is for 2 marks, so we have 1 mark to balance the equation. We have 2 nitrogens here on the right side, so we have to add 2 in front of nitrogen dioxide, and then let's balance carbon and oxygen. We have 4 oxygens here and 1 oxygen, so we have 5 oxygen in this side, and here also on the right side we have only 2 oxygens in carbon dioxide, so we have to change the 2 sides to be equal numbers. We will add 4 here in front of carbon monoxide. So the oxygen will be 4 plus 4. We have total 8 oxygen on the left side, and 4 by 2, we have 8 oxygen on the right side also. Now the equation is balanced. Question 2. A list of metal is shown. Copper, iron, magnesium, potassium, and silver. All metals form positive ion. Describe how metal form positive ions. Of course, positive ions formed when metal atoms lose electrons, so positive ions formed by losing electrons. State which of the 5 metals in the list have the greatest tendency to form positive ion. As the metal becomes more reactive, that means it reacts more readily and of course faster than other metals. That means it loses electrons more readily and faster than other metals. So as the metal becomes more reactive, it has a greater tendency to react, to form positive ions. So the most reactive metal in the list here is potassium. So potassium has the greatest tendency to form positive ions. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. Of course, catalytic properties are shown by transition metal, and the only 2 metals here, we have 2 metals which are not transition metal, magnesium or potassium. We can choose any one of them because copper, iron, silver are transition metals. So magnesium and potassium only cannot show any catalytic properties. State which of the 5 metals in the list is a major component of stainless steel. Stainless steel is an alloy of iron, so of course iron is a major component of stainless steel. A student adds sample of metal to an aqueous metal salt in a beaker to see if a displacement reaction takes place. Complete table 2.1 to show the color of the solution in the beaker at the start and at the end of the experiment. So we will add a metal to aqueous salt in a beaker and see if a displacement reaction happened. The first one here, the metal is magnesium, and the solution in the beaker is iron 2 sulfate. Iron 2 sulfate is a green solution, so the color of the solution at the start is green because magnesium is more reactive than iron, so it will displace iron from its salt solution. And now we have solution of magnesium sulfate, which is colorless, so the color at the end is colorless. Second one, the metal is silver and the solution is copper sulfate. Copper sulfate is blue, so the starting color is blue color, and because silver is less reactive than copper, it cannot displace copper, so the solution will remain blue and the color at the end will also be blue. Most of group 2 metals form a gas when placed into a cold water. An alkaline solution is also formed. Name the gas formed when strontium is added to cold water. When group 2 metals react with cold water, hydrogen gas produced. Exactly like the reaction of group 1 metal with cold water. Name the alkaline solution formed when strontium is added to cold water. Of course, the alkaline solution is a metal hydroxide. We have a strontium, so the product will be, or the alkaline solution will be strontium hydroxide. One group 2 metal reacts very slowly when placed in cold water. When heated, the metal reacts with steam to form a white solid. This metal from group 2 is magnesium, because magnesium is less reactive than calcium and than strontium, so of course magnesium will have a slower reaction with cold water and it can react with steam or with hot water. So identify this metal. The metal is magnesium, and when the magnesium reacts with hot water or with steam, a white solid formed, which is magnesium oxide. The reason for that, magnesium hydroxide formed is decomposed to form magnesium oxide due to the high temperature of the steam or the hot water. So in this case, we will not have metal hydroxide, we will have only the metal oxide because of the thermal decomposition of the metal hydroxide to metal oxide by heat. So the solid formed will be magnesium oxide. Under certain conditions, iron will react with steam to form an oxide of iron with the formula Fe3O4. Fe3O4 reacts with dilute hydrochloric acid to form a mixture of iron 2, iron 3 salts, and water. So we have three products formed when this iron oxide reacts with hydrochloric acid. Of course, the iron 2 and iron 3 salts will be chloride salt because the oxide react with hydrochloric acid. So one of the product will be iron 2 chloride and the other product will be iron 3 chloride, and of course also water will be formed. So the reaction of iron oxide Fe3O4 with HCl will give iron 2 chloride, iron 3 chloride, and water. We still have to balance the equation, so we will start by balancing iron. We have 3 irons, 1 iron here in iron 2 chloride and 2 irons in iron 3 chloride. We have 2 chloride here and 2 multiplied by 3 here. We have 6, so we have 8 chloride. We will write 8 here in front of hydrochloric acid. Now we have 8 hydrogens, so we have to put 4 in front of water. 4 multiplied by 2, we have 8 hydrogens and 4 oxygens already balanced. Now we completely balance the equation. Simple equation for the industrial production of ammonia is shown. Nitrogen reacts with hydrogen to form ammonia gas, and the delta H is minus 90 kilojoule per mole, means that the reaction is exothermic. Name the industrial process used to manufacture of ammonia. It is Haber process. State the meaning of the delta H. Delta H is the enthalpy change or the energy change of the reaction. The conditions needed for the Haber process, the temperature is 400 degrees Celsius. He's asking for the unit also. The pressure and the unit, the pressure is 20,000 kilopascal, or we can write 200 atmospheric pressure, and the catalyst is iron. State two methods of increasing the rate of reaction. We can increase the rate of reaction by increasing temperature or by increasing pressure. So the answer will be increased temperature or increasing pressure. The symbol equation for the reaction can be represented as shown: nitrogen plus 3 hydrogen to give 2 ammonia. He already gave you the equation in a displayed form. The bond energy is given here in the table. Use the bond energy in the table, and the delta H, it is already also given here, which is minus 90 kilojoule per mole. And use this table and the delta H to calculate the bond energy of an NH bond. So first we will calculate the energy absorbed to break the bonds in the reactant. We have 1 nitrogen bond for 945 and 3 hydrogen bonds. So we will multiply 435 by 3. The total energy needed to break the bonds will be 2,250. Then we will use the equation: the energy absorbed to break the bond minus the energy released, equal to the delta H, which is minus 90. We have the value of the delta H and the value of the energy absorbed. We can calculate the energy released, which will be 2,340. This energy released is from the formation of 6 nitrogen-hydrogen bond. So we will divide 2,340 by 6 to get the value of the bond energy for 1 NH bond, which will be 390 kilojoule per mole. An incomplete equation for the preparation of ammonia in the laboratory is shown. Calcium oxide reacts with ammonium chloride to form calcium chloride, ammonia, and a third product, which will be here water. So we will add water to complete the equation. Name this salt. The salt is ammonium chloride. Calculate the volume of ammonia measured at room temperature and pressure, which formed when 1.12 gram of calcium oxide is heated with an excess ammonium chloride. So first we will calculate the number of moles of calcium oxide. The number of moles equal to the mass divide the MR of calcium oxide. So we will divide 1.12 by 56. The MR is already given here. The number of moles of calcium oxide is 0.02. Then referring back to the equation, the ratio number of moles of calcium oxide to ammonia is 1 to 2. That means the number of moles of ammonia is double the number of moles of calcium oxide. So simply we'll multiply the number of moles by 2 to get the number of moles of ammonia, which will be 0.04. Then to get the volume of ammonia, we know the equation for number of moles of gases. Number of moles equal to the volume divide 24. So we'll multiply the number of moles by 24 to get the volume. The volume of ammonia will be number of moles, which is 0.04 times 24. It will be 0.96 decimeter cube. Then because the answer here is in centimeter, we will multiply by 1,000. So the volume of ammonia will be 960 centimeter cube. A carboxylic acid reacts with an alcohol to produce ester and water. Under certain conditions, the reaction can be reversed, so the ester reacts with water to produce carboxylic acid and alcohol again, because the reaction is reversible. The reaction reaches an equilibrium, and the forward reaction is endothermic. Deduce the empirical formula of the ester. To know the empirical formula, we will first write the molecular formula by counting number of carbon atoms. Here we have 4 carbons, 8 hydrogens, and 2 oxygen. So the molecular formula will be C4H8O2, and then the empirical formula is the most simple whole number ratio of the molecular formula. So we will divide the molecular formula by 2 to get C2H4O. This will be the empirical formula of the ester, and then we have to name the ester. to name the ester, first we will write the alcohol part. The alcohol part here have 1 carbon, so it's methyl, and we have 3 carbons in the acid part, so the acid was propanoic acid, and the ester name will be methyl propanoate. Name the carboxylic acid X and draw its display formula. As we've just said, the acid is propanoic acid, which is acid formed from 3 carbon atoms. The first carbon atom is the carboxylic group, so this is carbon number 1, 2, 3, and this is the displayed formula of propanoic acid. Name the alcohol Y and give its structure formula. Here he wants the structure formula of methanol, so it is CH3OH. This is the structure formula of methanol. Complete the table to show the effect, if any, for each change of conditions. The first one, if the temperature is decreased, what will be the effect on the concentration of carboxylic acid at equilibrium? I'll rewrite the equation back here to see how the equilibrium shift by changing the conditions. Here is the equation that was given in the first part of the question. Ester plus water gives alcohol and acid. And the question is asking about the concentration of the carboxylic acid at equilibrium. And it was also given that the forward reaction is endothermic. So first, by decreasing the temperature, if we decrease the temperature, the equilibrium will be shifted to this side, which is exothermic side, so it will be shifted backward. Of course, the concentration of the acid will decrease. Second, the concentration, if we decrease the concentration of the ester, so withdrawing the ester from the equation, that means decreasing the concentration of the reactant, the equilibrium will be shifted backward to form more of the reactant. Of course, the concentration of the acid also will decrease. More alcohol is added. If we add more alcohol, that means increase the concentration of the products, which is alcohol. So this will shift the equilibrium backward to decrease the concentration of alcohol, and this of course will also decrease the concentration of the acid. The last one, when catalyst is added, catalyst has no effect on the concentration of the products at equilibrium because it increases both the forward and the backward reaction by the same value or by the same amount. So catalyst has no effect on the concentration of the acid at equilibrium. At the beginning of the reaction between the ester and water, no carboxylic acid is present in the mixture. Suggest how the pH of the reaction mixture change from the start of the reaction until equilibrium is reached. First, there is no carboxylic acid. We only have ester and water. Ester and water are neutral, so the starting pH will be 7. After the reaction, after the equilibrium is reached, we have carboxylic acid, which is weak acid, so the pH may be 4 or 5. We can write 4 or 5. Both are correct answers. So the starting pH is 7 and the final pH or equilibrium pH will be 4. Identify the ion that causes the change in pH. Of course, it is the proton from the carboxylic acid, H+. This is the ion responsible for making the acidic pH, so we will write H+. Name an indicator which you can use to follow the change in pH, because a universal indicator gives a different color according to the pH, so we can use universal indicator to follow the change in pH. Question 5. Sulfur is in group 6. A symbol of sulfur contains 2 isotopes, sulfur 32 and 34. Complete the table to show number of protons, neutrons in one atom of each isotope of sulfur. The first isotope, sulfur 32, of course we will search in the periodic table to know the number of protons for sulfur. It's 16, so number of protons will be the same for the both isotopes, 16 and 16. And to calculate the number of neutrons, we will subtract 32 minus 16, it will be also 16. 34 minus 16, it will be 18. So the 2 isotopes have the same proton number but different neutron number. State why these isotopes have identical chemical properties. They have identical chemical properties because they have the same electronic configuration and the same number of electrons in the outer shell. State the mass of 6.02 times 10 to the power of 23 atoms of sulfur 34 includes units in your answer. A mass of sulfur that contains this number of atoms, this number is Avogadro's constant. So the mass contained Avogadro's constant number of atoms is 1 mole. 1 mole of sulfur 34, of course, have 34 grams. So the answer will be 34. State the name of the amount of substance that contains this number of atoms. As we've just said, this is Avogadro's constant, and Avogadro's constant is contained in 1 mole of any substance. So the name of this amount will be 1 mole. The table shows the relative abundance of these isotopes of sulfur in the sample. We have 2 isotopes, the first one 95% and the second is 5%. So we will multiply the sulfur 32 by its percentage plus the sulfur 34 multiplied by its percentage, divide 100. The relative atomic mass of sulfur will be 32.1. Sulfur reacts with magnesium to form magnesium sulfide. Magnesium sulfide is an ionic compound. Complete the dot and cross diagram for the ions of magnesium and sulfide ions. Magnesium is in group 2. It has 12 electrons, 2, 8, 2. When react, it forms a positive ion. It loses these 2 electrons. So the electronic configuration of magnesium ion will be only 2, 8. We will draw 8 electrons. That will be the outer shell of magnesium, and the charge plus 2 because magnesium loses 2 electrons. These 2 electrons will be gained by sulfur atom to form sulfide ion. So now we have sulfide ion with extra 2 electron. It will have a negative 2 charge, and the outer shell electron of sulfur will be 6 dots because sulfur is in group 6. It has 6 outer electrons, and 2 crosses because 2 electrons are gained from magnesium. Now sulfur has a complete outer shell of 8 electrons, 6 dots, and 2 crosses, and the charge will be -2. State why magnesium sulfide has high melting point. Magnesium sulfide is ionic compound, and the strong ionic bond in magnesium sulfide need high amount of energy to break it. That's why it has high melting point, due to the strong ionic bond between positive and negative ions. State why molten magnesium sulfide conduct electricity. The ionic compound can conduct electricity either molten or aqueous because it has free moving ions. An acid contains sulfur, react with sodium hydroxide to form salt and water. The salt has the formula of Na2SO3. Deduce the formula of the acid. Because here we have 2 sodium, so the charge of the sulfide ion will be -2. It can be balanced with 2 hydrogens because each one has 1 positive charge. So the formula of the acid will be H2SO3. This is the sulfurous acid. Deduce the formula of the anion. Of course, as we've just said, the anion will be SO3 -2. Sodium sulfite is oxidized by acidified aqueous potassium manganate 7. State what 7 refers in the name of potassium manganate. This number refers to the oxidation number of manganese in potassium manganate. State the color change when the reaction happens. When potassium manganate react with the sulfide ion, the purple color of the potassium manganate change into colorless. So the observation that the color will change from purple to colorless. Question 6. Glucose is involved into 2 processes. Glucose is made in plant from carbon dioxide and water. Name this process. When glucose is made in the plant, this process, of course, is photosynthesis. Write a simple equation for this process. In photosynthesis, carbon dioxide react with water to form glucose and oxygen. Then we have to balance the equation. 6 carbons, so we write 6 here, 12 hydrogen, so we have to put 6 in front of water, and again 6 in front of oxygen. State 2 essential conditions needed for this process to happen. 2 essential conditions for photosynthesis, of course, energy from light and chlorophyll in the plant cells. Glucose is converted to ethanol. Name this process. The formation of ethanol from glucose is by fermentation, so the process is fermentation. Name the other product formed when glucose is converted to ethanol. The other product is carbon dioxide, which is formed due to the anaerobic respiration of yeast. Ethanol is made by ethene with reaction of ethene with steam in an industrial process, which is the catalytic hydration of ethene with steam. State the conditions needed and the type of the catalyst used in this industrial process. The condition is 300 degrees Celsius, this is the temperature, and the pressure, 60 atmospheric pressure. The type of the catalyst is acid. Actually, the catalyst is phosphoric acid, so the type will be just acid. Explain why the reaction is an addition reaction. Addition reaction is the reaction that produces one product only, and when ethene reacts with steam, it forms one product only, which is ethanol. So this reaction is addition reaction because only one product is formed. Complete the dot and cross diagram for the one molecule of ethanol. So I will first draw the ethanol molecule. Here the first carbon form 3 single bonds with 3 hydrogen and 1 bond with the second carbon. The second carbon also have 2 single bonds with 2 hydrogen and 1 single bond with oxygen. The oxygen form another single bond with the last hydrogen. So we have 4 shared pairs of electron around the first carbon, 3 with the 3 hydrogen, and the fourth bond will be with the second carbon. Here 1, 2, 3 shared pairs of electrons between carbon and the 3 hydrogens, and the fourth pair will be with the second carbon. The second carbon will also have 4 pairs. This is the first one with the first carbon and 2 with hydrogen. The fourth will be with oxygen. Now we have 1, 2, 3, 4 shared pairs for carbon, and oxygen will have only 2 shared pairs, one with this carbon and one with hydrogen. And to complete the outer shell of oxygen, we have to draw 2 lone pairs. Now the outer shell of oxygen have 8 electrons, and we have 2 electrons in each outer shell for hydrogen. This is the complete cross and dot diagram for molecule of ethanol. Now we've reached to the end of our exam. Comment down below if you have any questions. Like the video and subscribe to the channel to receive all the updates. Thank you for watching. Wish you all best of luck.